Rutherford's model of an atom.
Hi students. Today we are going to learn about Rutherford's model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. Let's see how he conducted the experiment.
Hi, I'm Ernest Rutherford. I'm famous for discovering the nucleus of an atom with the gold foil experiment. In this experiment, I made fast-moving alpha particles fall on a thin gold foil. I selected a gold foil because I wanted as thin a layer as possible. Gold was the best option because it is highly malleable and lustrous.
The alpha particle scattering experiment gave totally unexpected results. Let's see what were the observations made.
Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. This result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you.
Rutherford concluded the following from the alpha particle scattering experiment.
Firstly, most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. Secondly, few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. Lastly, a very small fraction of alpha particles were deflected by 180 degrees, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. And that the nucleus is small, hard, dense and positively charged.
On the basis of his experiment, Rutherford put forward the nuclear model of an atom. Does anyone know what were the features of the model?
Yes, ma'am. Firstly, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The second feature is that the electrons revolve around the nucleus in circular paths. Lastly, the size of the nucleus is very small as compared to the size of the atom.
Excellent. That's absolutely right. Rutherford's model of the atom had some drawbacks too. According to his model, the revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. But this is not true. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. We know that atoms are quite stable. Okay students, that's it for today's class. Next class we will learn about Bohr's and J.J. Thomson's model of an atom. Hi. Be sure to like, subscribe and comment on this video.